Hi gang, it's Mike Wooligal. It's September 22nd, 2013, and I'm going to do a little video podcast here for you today. Basically, I'm going to show you one of Jeff Raskin's Swift cards and how it works. Do it live and set it up and run it. So before I get there, I would point out it's just recently come to my attention. There's a person in Boston trying to set up a museum in Boston again for vintage computers. It's called digital-den.org. Go over there, take a look, and basically wish Mary and the crew there the best of luck in trying to get another computer museum in Boston. I really miss and was disappointed when I found out the last one was dismembered and most of the artifacts went out to Mountain View, to the Computer History Museum out there. So anyway, let me jump. I'm going to basically show you the Swift card. I'm going to show you I built using a Super Proto a working functional reproduction of the Swift card, and then I have a real one now, and also show you how a little bit about how I reverse engineered it. So let me move the camera over and I'll go to the next step. Okay, so what we got here, let me adjust the lighting a little. I definitely do not have a studio quality setup here. This is just the corner of my basement, a tiny corner. I'm constantly tripping over stuff here and constantly running out of room. So what I have here, the Swift card ran in an Apple IIe. So I have an Apple IIe here, and on top of the case you can see several things. First of all, maybe the most interesting is the Swift card itself. And let me tell you a little bit about this. Jeff Raskin was a original head of the Macintosh team at Apple, and he had this vision of a very simple, easy to use computer, and he and a couple other guys were basically working toward that end goal. Well, when Steve Jobs got involved, I guess their concepts differed a little bit, and eventually Jeff moved on, left Apple to leave Steve to continue with the Macintosh program and develop it in Steve's vision of what a Macintosh should be. Meanwhile, Jeff founded a company called Information Appliance Inc., and the first product was the Swift card, which ran in an Apple II, and it basically was a proof of principle firmware card for the Apple II that basically ran the firmware, the software that they thought should be the basis of their product. And they eventually developed a product called the Swift computer, and you'll see what it does in a minute when I demo it. And eventually they got Canon interested in it, and Canon came out with a version called the Canon Cat. But essentially all the fundamental operations of a Swift computer or Canon Cat are encapsulated in this firmware that runs an Apple II. Now, I read somewhere on the net they sold about 200 of these cards, or up to 200, although there are advertisements in magazines of the era for this card, so I don't really know how many they sold, but I managed to get a hold of one. There is a Google group called Canon Cat, where the Canon Cat, the Swift computer, and the Swift card for the Apple II are discussed. So if you're interested in more information or have questions, more questions, there's a place to go. Up here is one of my Super Proto cards, which I modified to operate like a Canon Cat, like a Swift card. It has Swift card firmware burned into it, identical. It has a basically, I'll talk a little bit about the components of the Swift card. I can do that either with my Super Proto or a real Swift card because they're essentially the same with one difference. But anyway, there's a PROM on it. In this case, on my Super Proto, I use an EEPROM. There's a PAL or GAL. The original Swift card used a 16R4 PAL. Oh, that's a little out of focus. I don't know what's going on there. But on my Super Proto, I use a 22V10 GAL. But essentially, they do the same function. And then there's an LM311 with some supporting circuitry on both cards. Oh, I'm kind of probably making you dizzy here. The LM311, the only purpose of that part is to extend the system reset so that when the Apple came up, the last, basically this Swift card controls the reset of the system. So when you power up that LM311, a search reset holds it on the whole system for longer than anything else would. So when you come out of reset, it's controlled by this chip, and that's all that does. And then there's the like I said, the PAL, and the PAL just does a little extra stuff on the bus interface to make sure that the PROM works well. Note that it's a 16K by 8 PROM, and the firmware space of an Apple II is 12K. So basically, if you break the 16K into 4 sections, you've got basically one extra section. So you'd have 12K, the address into the 12K of the Apple II firmware space. So what they took with that other 4K is they did some bank swapping. So you can actually access the whole 16K on that 16K by 8 PROM. And the PAL there helps do the addressing of which bank. So basically there's 2 banks that are fixed and equivalent to Apple 4K banks, and then there's another one that can be swapped depending on, they actually use a signal called device select. So anyway, to understand more about that PAL, PALs have a bit called that basically prevent you from reading them, and that was burned on this cards, so I wasn't able to just read the PROM back and copy it. So what I did is I built this jig on a breadboard that basically allows me to, basically on the right side of it there's a 555 timer that generates a clock, and then I plug in that PAL, and on one side of the PAL I use those jumpers to either pull up or pull down the inputs, and then on the output side I just use the scope on the chip, on the legs of the PAL itself. So originally I had the PAL plugged in there when I was doing this. So I basically was able to completely reverse engineer the PAL. So I know exactly how it was designed. The one I did, when I did this Super Proto, I didn't have a Swift card, so I just used the description in the documents and the schematics which are on the documents to figure out how it works. So the one on the GAL on the Super Proto is not exactly the same functionality. I mean, functionally it's the same, but the actual implementation is slightly different than our real Swift card. It really doesn't matter in terms of operation. And I have all the data you need on my Super Proto wiki page for you to convert a Super Proto into a Swift card. So let me, so that's kind of a high-level summary. So on the Apple IIe, you need a basically an Apple IIe with a Swift card and a disk drive in slot 6. So let me go ahead, set this up, and I'll show you how it works. So let me move this stuff out of the way. These here are extra gals I built. I actually used 16 R8 or no 16 V8 gals, and they plug right into the slot that had the 16 R4 on the original Swift card. So they're perfectly functional. So let me move these aside. The Swift card plugs in slot 3. Note that if you have a firmware card, well, it goes in Apple IIe, so there's no slot 0 to put a firmware card, so this should just work. So that's pretty much it. You plug it in. There's nothing to configure. Just make sure you have a disk drive in slot 6, and you're ready to go. So let me rearrange the video a bit. I don't think I need to show you to power up, so what I'll do, I will set up the video on the monitor. Now you need an 80 column card here on the monitor. So let me see. Okay, the monitor's on. Let me flip on the Apple II. Now right now I got no disk in the disk drive. I got the disk open, so we'll see how it comes up. The Apple II is not plugged in. Let me flip it off, plug it in, flip it on. There we go. And you can see the startup logo, and you're ready to go. It starts up really fast. And on the Swift card, it basically uses the Apple keys, the control keys, to support your typing. So I don't know if you can see this in the video. Let me zoom in a bit more, because it's at 80 columns. This thing's so I can type in my name is Mike. Okay, and there, you basically you're entered into a word processor right away when you get into the Swift card. The bars across are basically page breaks. So if I want to go to the next page, geez, I forgot that command. But you can basically type here all you want. Now the interesting thing is you can also do on the Swift card to navigate, you use the Apple keys. So if I hold down the Apple and type some letters, it'll try to find that letter in the text and take the cursor to that text. So if I hold down the left Apple and type MY, the cursor goes to my. And that's how you navigate on the Swift card. If I hold the left Apple, I'm going backwards. If I hold the right Apple, you'll go forward. So if I hold the right Apple and type KE, it goes to the KE. And if I just want to go one, I can just hit the right Apple. So if I want to select a block of text on the Swift card, I basically got a cursor here. What I do is I'll hold down the Apple and type the text I want to go to. So I'll hold down left Apple, M, Y, and it goes to the MY. Now there was a previous spot where it was in the current spot, and you hold down both Apple keys and it'll select everything from previous to the current. So that's the way to select a bunch of text, and you can delete it and paste it and move it and copy it. So that's kind of the highlight. Now they have a built-in way to get to BASIC from the Swift card. So if I want to say do something in BASIC, like I'll type print 56 times 88. Okay, so that's a basic statement, right? So I'll go, so I'm at the end, so I'll go to the P and I'll select both, and they have a command called calculate. which is on the Apple keyboard, is Control G. So I'll type Control G, and 4928 is the answer. So you can also put in little basic programs. Now on the real Swift computer and the Canon Cat, I think they go to fourth instead of basic, because the fundamental of the firmware is a fourth interpreter. But I can write a little basic program here. I should be able to. So let me go forward a little bit using the right Apple. So I'll type 10 for I equal 1 to 10, 20, print. Whoops, I made a mistake. Let me just back up. Print I'm at, and then I. So this is just AppleSoft Basic, right? And 30 next I. So if I want to go back, say I got extra space in there, if I want to go back, I hit left Apple return, it'll find the previous return. So there's no real, the arrows don't actually work on this thing, and they make a big point of that in the manual. So if I want to select all of this, I got to go back by holding Apple 10, and then if I hit let it Apple up, push Apple down again, and go tab, it'll do it again. So I got my cursor, my start. I want to go to the end, so I want to go Apple space I, and I want to do it again. Lift up the cursor, go tab, lift up the cursor, go tab. Okay, so I'm at the end. Oh, I didn't select it all. So this thing's a little quirky, you know. So let me go back to the. Well, I can go back to carriage return, right? Let me go to the end. Okay. Let me go to 10 space F. 10 space F. And then hold it down. I selected the whole thing. Now to get this basic program in memory, I type Control G, which is their calc command. So I just did that. So I should be able to type list, and then Apple L, select it all, and do a Control G again. And there's my programs in memory. So to run it, what I do, I type run, Apple R, select it all, and then Control G. They say, you know, it's kind of funny, they say front G in the documentation, but front's mapped to control on the Apple keyboard. When I say using the Apple key on the documentation, they say use the leap commands. There's a leap back and a leap forward. Leap back is the open Apple, leap forward is the closed Apple. And you're supposed to put stickers on your keyboard to overwrite, you know, the current symbolism. But you know, for my mind, I haven't put stickers on my keyboard, so I use the Apple naming of the keys. So I have run highlighted. I'll do Control G, which is in their terminology front G. And the reason why they say front is you're supposed to put stickers on the front of the keys for these alternate commands. So there it ran my little program. I'm at 1 through 10. So that shows you how you can edit, move around the editor, run basic programs. So now, one of the neat things is if you reset the system, it comes back exactly where it was. So right now, I'm right here. I'm in the middle of this text. Right? I'll hit Control Reset on the system, and it comes right back to where it was. So that's one of their redeeming features. Now the other thing about a Swift card is there's no operating system to load. All the operating system's on the firmware card. So I haven't booted anything off the disk. When I first powered up, it looked for a program on the disk. Well, actually, what it looked for was a document on the disk. The way this card works is every floppy is its own document. So if you change floppies, you're putting a new document in the system. So right now I have the floppy door open. I couldn't find anything when it booted. So if I close the floppy door, there's a command called front L or control L, which will save whatever you have to disk. So I'll try it right now. And it reads the disk and it beeps. And the reason why it beeped is I have a different program on the disk, okay, than what's in memory. So it's not going to overwrite that program on the disk with what's in memory. However, there's a backdoor to overwrite it, and that's doing a call command. So if I get a new line here, I type call 3600. It will basically initialize the floppy. So I gotta highlight this Apple, or in the I guess I'm not totally committed to this thing. I would say leap back to C, and then both leap keys highlights call 3600, and then I'm telling you what I'm doing because I can't show you, both what's going on the keyboard and the screen. Now Control G or front calc, and it's supposed to reinitial. It's not working. Okay, it's stuck. So I control reset. It comes back to where it was. Now I'll try call 3600. I obviously did something. Oh, I got call 360. So it called 360 into memory, which obviously isn't going to work. So I got to add a 0. Okay, so now leap back to C. Both leap keys highlights it, and then Control G or front calc, and it reinitializes the disk. And then if I hit Control L or front L, it's actually going to save it. Okay, so it saved it. So now I've got a floppy initialized with this. Whatever I had on that floppy before is gone. Okay, so now is kind of the neat thing. So I'll power off the machine. Powered off, nothing on the screen, nothing in memory. Turn it back on. It reads, powers up, reads memory, and I'm back exactly where I was. So that's one of the neat features these guys, Jeff Raskin and Information Appliance Inc. came up with, is the basic philosophy of one document per floppy. So they could basically, whatever flop you have in there kind of tells you what's the state of the system. The downside is if you want to copy this data to a new floppy, you basically have to basically pull your floppy out, put a different floppy in, reinitialize it, save everything. So it's I don't know. Certainly with the size of the storage we had now, if they had stayed in business, they would have had to gone to some other method and supported a real file system. But this was kind of their thought process. So that's a bit of a demo. I think it shows the highlight. It kind of shows. They also had, I'm going to talk about this. I haven't actually done it. Now that I actually have a Super Proto that works with a Swift card, if I had another Apple IIe, I could do this. But they have, basically, if you have serial interfaces in two systems, you can move data back and forth between systems. They also have printer functionality if you have a printer on your system, so you can basically, and it works kind of the same way as I showed you for the basic. You highlight a bunch of text and you want to send a bunch of text to another computer. You highlight it, and then there's a control command, or what they call a front command, that sends it to the other disk, to the other computer. I haven't actually done it. I only have one Apple IIe. If I had another one, I could do it. If I bothered to hook up my printer, you could also print the same way. You basically highlight a bunch of text and you send to the printer. But you can also cut and paste. I don't have those down. I don't have the document in front of me. But anything highlighted, you delete. You can kind of put back somewhere else. People that are familiar with like the VI editor in the Unix environment would be familiar with deleting a bunch of cut and paste that way. Is very similar in certain respects to that. So that's about all I'm going to do right now, but it kind of gives you a highlight of what the Swift card's about, and so let me know if you're interested in one of these cards. I could possibly make some reproductions. It's wouldn't be too expensive because they're very small, simple cards. But let me know what you're interested in. Let me know what your feedback is. Thanks.